Welcome, Math 252. We're looking at problem 27 from section 5.3 of the Hughes-Hallett text. In this problem, we've been given a function W, which is a function of T. W gives us tons per week of waste produced by a company, where T is the number of weeks since the start of January 1st, 2005. Waste removal for the companies costs $15 a ton, and we're supposed to figure out how much the company paid for waste removal, or will pay for waste removal in 2005. So here's my plan to get at this problem. I'm going to try to figure out how many tons of garbage the company produced in all of 2005, and then I'm going to multiply that number by $15 a ton to get their costs. This is pretty clearly going to answer the problem. The thing I want you to remember from this section is the most important fact in this section, and that is that if you have some function that's nice enough, and almost every function you're going to meet in this class will be nice enough, then when you integrate its derivative, so we have a function f, we're integrating its derivative from a to b, what we get is the change in f. We get f of b minus f of a. This is the fundamental theorem of calculus. Now let's see if we can use this fact to somehow approach this problem. What I'm going to do is construct a new function, g of t. I use g for garbage. And g is going to represent the number of tons of waste produced in the first t weeks of 2005. So g is giving me the total amount of waste as t grows. It's giving me the total amount for the year. The function wt given in the problem is the derivative of g of t. W is being measured in tons per week. It's given me the rate of change of G over time. It's the derivative of G. We also know that in 2005, when the year just started, we hadn't produced any waste yet. So G of 0 is 0. So now I'm going to apply the fundamental theorem of calculus. It says that G of 52, or G of 52 minus G of 0, they're the same thing, is the integral of W from 0 to 52. Why is that true? It's because W is the derivative of G. When you integrate the derivative, you get the change in the function. And then we have an expression for W, which was given by the problem. So if we can find this integral, which I'm about to do on the graphing calculator, then we will have G of 52. G of 52 is the total number of tons of garbage produced during all the year. So let's go over to the graphing calculator, and I don't know, let's turn the graphing calculator on and then go over to the graphing calculator, and let's put in this function, which is 3.75 times e to the minus 0.008 x. And let's set up the window. We're going to have x's that run from 0, the beginning of the year, to 52, the last week of the year. This function is always going to be positive, and since it's a decreasing exponential, it can't get any bigger than 4. Well, it can't actually get any bigger than 3.75, but let's draw that and see what it looks like. So there you see our exponential function. Remember, this is the derivative. It's showing us tons of waste per week. And what we want to do is integrate it. We want to find the area under that curve. So I'm going to use the calc feature on the calculator, option 7 down here. And I'm going to start with week 0. And I'm going to tell it to end with week 52. And I'm going to have it go ahead and compute that area. And when it computes that area, we are going to see, I hope, sure enough, 159.52487. That's exactly how many tons of waste were produced during the entire year. So in order to get costs, we take that number and we multiply it by the $15 per ton, and we get 2392.873098. But I think we can stop at 0.87, and that's what I've written over here. We got G of 52. The total number of tons produced was this number, 159.52, and multiplying that by $15 per ton got us our costs.